Hello guys, how are you today? And I'm back with another video. Jalaj Aurora here again, back with another video. And today I'll be doing section 1.3, C1.3 of the textbook, of the, the chemistry, GCSE chemistry revision guide, Kabuto AQA textbook basically. And I've shown you this in every single video I've made so far. I'll show you it again. I'll keep showing you it, just in case you haven't seen it before. And just before we get into the video, there was a slight mistake I made in the last video. I watched the video back after uploading it. It's not really a massive mistake, like you're not going to lose marks for it, but it's still very, very, crucial to just get the minor things correct, isn't it? Just in case. So what I'm saying is basically, this is the balanced symbol equation for hydrogen gas reacting with bromine gas to form hydrogen bromide. So so basically the mistake that I made was I put a 2 here, you can see, which is right, and then I changed the bromine from a 1 to a 2, which is also correct. But what I forgot to do was, because now there are 2 hydrogen atoms as well, because I put 2 in front, originally there was 1, I crossed out the 1 but I forgot to put 2. So now hopefully you can see that I did put 2. Ignore that kind of scribble, but there's a 2 if you can see it, hopefully. So that was basically the mistake that I made. And I saw that and I thought, I might just, flag that out in this video just to avoid any confusion or, But today we're doing separating mixtures, which is actually quite a short topic, like much shorter than chemical equations, I think. Separating mixtures 1.3. There is a 1.4 as well, I believe. Yeah, there are, different. It's not, that's different, but 1.3 separating mixtures. So, what is this all about? A mixture is made up of 2 or more substances, which are elements or compounds, that are not chemically combined together or chemically bonded together. The chemical properties of each substance in a mixture are unchanged. So these chemical properties of the substances in the mixture are unchanged. So mixtures are separated by physical processes. Physical processes do not involve chemical reactions, so no new substances are made. Now, physical processes include filtration, crystallization, and distillation. So they're the 3 main ones. But by the way, if you're following the student book, which is the big book, it's pages 8 to 9 that you should be on in order to follow with this lesson. Also, if you're following the student book, and for this topic, I think it's good to also look at the student book, because they have a very nice table that tells clearly kind of tells you the 3 main differences between compounds and mixtures. And what I just read out now is kind of it's quite a little summary, but I think it's better to actually look at that table there. I won't go through that table now, but basically go through that table on page, I think probably page 8 of the student book, and they tell you the difference between compounds and mixtures, and I think that's really helpful. But that's the first 2 done. So basically the 3 main ways. 1 minute, sorry about that. Just turn the phone off. By the way, for the first section I recorded on my phone, but because of the storage space issue, which you would know about if you saw that first video, I have now changed to actually recording on my laptop, which means now I have much more space available. So if the video does get a bit longer, it won't stop me from making it. So just wanted to tell you that as well, which I used my laptop for the last video as well. I'm using it for this video as well, and I'm probably going to use it for all the videos I'm going to make now. But getting back to the topic, the 3 main ways of separating mixtures are basically these physical processes. By physical means are filtration, crystallization, and distillation. So what is filtration? Filtration separates substances. It's a physical technique, physical process that separates substances insoluble in a solvent from those that are soluble in the solvent. For example, sand can be separated from salt solution using filtration. So you can use filtration to actually, because sand is basically insoluble in water. So basically what happens is sand can be separated from a salt solution using filtration. And that's a quite useful process. What about crystallization? So crystallization basically separates a soluble solid from a solvent. For example, salt from a salt, which is basically sodium chloride, NaCl. That can be separated from a salt solution, and you can use crystallization to do this. Another very useful technique, actually useful physical process. And then distillation, what is that? Well, that separates a solvent from soluble solids dissolved in the solvent. For example, seawater is distilled to obtain usable water. So basically what they're saying in distillation, what you do is basically you're separating the solvent from the soluble solids. So actually you're trying to collect the water part, or the solvent part. It doesn't have to. Water is not the only solvent that there is. There are a lot of different types of solvents, and basically whatever solvent you're trying to separate that from the soluble solid. And what's left, basically your soluble solid, is actually known as the residue. That's not actually written here, but just trying to tell you something as well. They might ask in the exam that when you do distillation, what is the soluble solid that remains called, and they could well ask you that. And it's good to know the term, and it's residue. So they're the three main ways of separating. Basically, they're the three main physical processes that you can use to separate mixtures and stuff like that. So that's really interesting, actually, and really cool. So name the three methods of separating mixtures. So that's actually a question on here. So basically, when I kind of say a question, I'll just tell you that yes, it's a question in the revision guide. So this is a question, and three main methods of separating mixtures, and these are, we just went through this: filtration, crystallization, and distillation. And I haven't also mentioned that the big book is very helpful for this as well, not only for the compounds and mixtures kind of distinction, which is obviously very important to understand, but also it actually goes through these kind of three processes in a lot more detail, because obviously this book just gives 2-3 lines for each, but that's assuming that you kind of know the basics already about what happens in each process. But if you don't, I would highly recommend that you actually go through the student book as well, which is the big book, as I said before. And because that actually explains, I think that's why, I was criticizing, I'm not criticizing, but I was saying that book isn't very useful, but it is kind of useful for these kind of things, explaining things when you haven't really maybe covered it, or when your knowledge is a bit shaky. Whereas this book, which I use, I'll show you it again, the book I'm using, that book is good once you've actually done the topic once or twice and you know kind of how it works. Good refresher. This this book gives a very good refresher of kind of the topic, and it's very quick, I think, very short, snappy, and yeah. So let's move on from that. So the three methods of separating mixtures are filtration, crystallization, and distillation. And again, if you want to know kind of more about them, kind of more detail about them, because you could be asked to actually explain it in detail, then I'd recommend you check out the student book. And then the next question is, which method would you use to separate sand from a mixture of sand and water? Remember, that's separating an insoluble solute from a soluble solvent. I think that was, substances which are insoluble in a solvent from those that are soluble, basically. Better to say substances, not solute, but basically the method you're going to use here is filtration, as I mentioned previously. Talked about filtration before, and the key word of this topic is, there's only one keyword here, which is filtration. That's the only keyword. But to be honest, I think crystallization and distillation are also quite important words, because it's not in here, but I think it's not written on here that they are keywords, but they are, I think, in my opinion, very important words, because you could be asked about them in the exam. How do you carry out distillation? Like, what is the process? What kind of things is distillation used for? And or even with crystallization, the same kind of questions can be asked. So yeah, very important to understand these three processes. But a mixture is made up of, so now we're going through the key points just before we end the video. So a mixture is made up of two or more substances. That could be elements or compounds, I believe. Yeah, elements or compounds these mixtures can be made from two or more substances that are not chemically combined together. Now that's very important. It's made from two or more substances that are not chemically combined or chemically bonded together. Because if they were chemically bonded together, we wouldn't be able to kind of separate them by physical means. We would have to use chemical reactions, to separate them, or chemical means we'd have to use. So, and the last kind of key point is mixtures can be separated by physical means such as filtration, crystallization, and simple distillation. I want to kind of just talk about this point of simple distillation, because basically there are two types of distillation. There's simple distillation and there's fractional distillation. It's fractional distillation, that's what it's called, isn't it? Yeah, fractional distillation, yeah. Just looking at 1.4. So we're going to encounter fractional distillation and another technique called chromatography in the next section, which is 1.4, which I'll do tomorrow. But the distillation we were talking about here was simple distillation, and tomorrow I'll tell you the difference between simple and fractional distillation. I'll talk more about it, but basically at the moment you need to know the three main ways, the three physical means. The mixtures can be separated by physical means, and these three physical means are crystallization, filtration, crystallization, and simple distillation. And also here there's just a little synoptic link that to find out more about crystallization and distillation of seawater, see topic 5.5 and 14.2. That's at the moment a long way off, so we'll see that when it comes. But I think that's going to be the end of the video, guys. If you found this useful, please like the video, share it with other people. Make sure to subscribe if you haven't already, and basically make sure to share, like, and subscribe. And I'll see you in the next video. And also, I don't think I mentioned this in the last video or the video before that, but basically please keep the notification bell on, so that when I upload videos you'll get a notification, basically, so you can watch my videos. So hope it was helpful, guys, and I'll see you tomorrow for the next video. Thank you very much, guys.